I'm Francis Rose. Thanks for joining our webinar, Inside SPAWAR, the role of information warfare in maritime superiority, presented by Vion and Dell EMC. Before we begin, please take a moment to respond to a few simple polling questions. We'll start the program right after this. Thanks for watching Inside SPAWAR, the role of information warfare in maritime superiority, presented by Vion and Dell EMC. I'm Francis Rose with the Government Matters Thought Leadership Network. The Navy's Space and Naval Warfare Systems Command is the force's lead in developing, delivering, and sustaining information warfighting capabilities. Today, you'll get an exclusive look inside SPAWAR. Rear Admiral Boris Becker, SPAWAR's commander, just announced a rebranding of sorts. SPAWAR Systems Center Atlantic and Pacific are now Naval Information Warfare Center Atlantic and Pacific. Both are pushing hard to deliver on Admiral Becker's tech-forward mission.
The change will be effective as of the 19th of February, and that change is that we have renamed our SPAWAR System Centers Atlantic and Pacific to Naval Information Warfare Center Atlantic and Naval Information Warfare Center Pacific, or NIWC for short. A couple reasons for that change. If you had the opportunity to hear the CNO's opening comments this morning, you understand that very clearly the impetus for a change in how we look at the current world situation. Everything from the national security strategy to the national defense strategy leads to the design for maintaining maritime superiority version 2.0. And in that document, and in the direction we received from those other documents, you see the prevalence of the need for being ready to deter, to compete and win across the board, but in particular in the information warfare domain. And as the Information Warfare Systems Command, SPAWAR, I think, well, it was time for us to look at our system centers and change that name to Naval Information Warfare Center to focus our efforts and to key off of the defense strategies that tells us this is serious business.
In the time that you've been the commander, I don't know of a time where the integration of information into the warfighting sphere has been more intense. How have you tried to shape the way that SPAWAR executes the mission of the National Defense Strategy and the organization itself in the year or so that you've been the commander there, sir?
Last year, in 2017, I put out a vision document, a vision that took us out 10 years. And you might ask, how, as a nominally IT-based organization, can you have a 10-year vision? And my answer to that is, how can you not? We have to have an idea of where we want to go and where we want to be 10 years from now. And to do that, we laid out a couple of different lines of operations. I think we've made great progress against those lines of operations, and I think they've remained consistent with this focus from the National Security Strategy and the National Defense Strategy and the Design 1.0 and even 2.0. We've got to be able to move faster with delivering capabilities, modernizing capabilities in the information warfare space. At the same time, we've got to look at our cyber resiliency and recognize that battlefield, the cyber battlefield, is one in which future conflicts are being won or lost. and we have to increase the resiliency that we have throughout our fleet. And then lastly, looking at our organization, at our processes, and our people. Are we shaped properly? Are we as effective as we can be? Are we delivering the structures around which our people can be as successful as they want to be, as they can be, as we need them to be? And I think we've made progress against each of those three areas.
One of the things that strikes me about the mission of SPAWAR is the kinds of work that your teams are doing are not just designed to accelerate the capabilities and warfighting power of the Navy. Advertently or inadvertently, they're reshaping the way that leaders like CNO and others think about what the Navy looks like in 5 or 10 years. Can a drone swarm at some point replace a piece of aircraft, or does an unmanned aircraft replace a manned aircraft, and so on? How does that fit into when you're trying to build a 10-year strategy and then execute on it? How does that kind of conceptual thinking influence the way that you build a strategy like that, and also influence the way you execute it?
Well, I would say it simply directly. It influences that directly. As an example, as we look across the other systems commands, Naval Sea Systems Command, Naval Air Systems Command, I think we are at a level of integration and interoperability between our systems commands and our systems that we have never seen before, and that's being driven by the need to have information at the core. Information that supports missions like precision navigation and timing, command and control, battle space awareness, integrated fires, but also the very missions of those platforms themselves, below the sea, on the sea, in the air, in space, and through cyberspace. As we say at SPAWAR, we deliver capabilities from seabed to space and through cyberspace, and that is with and in conjunction with and in cooperation with and integrated with our other systems commands. Again, going back to your first question, another reason to acknowledge that we have information warfare centers, much like we have air warfare centers, undersea warfare centers, and surface warfare centers.
One of the challenges that has manifested itself department-wide in trying to increase the speed at which these technologies come into the department, come into the forces, and then go to the tip of the spear is the acquisition process. What's your sense of the tools that you would like to have, or the tools that you're leveraging to be able to do that, whether it's through partnerships with private sector, academia, NGOs, and so on? What's really driving the successes that you're having, and what would help to make those successes happen faster?
Part of that answer is technical, part of that answer is process, and of course part of that answer is people. I'll give you a couple of examples of I think, what highlight our advancements in that area. On the technical side, we put in place a cloud in the research and development environment that allows us to apply the sort of commercial processes and development and operations, or DevOps, secure DevOps, that will allow us to move at speed, going from design environments with our industry partners to development environments and test environments to a production environment at speeds at which we could not do before. That's in place, that's happening, we're using it. That is progress. On the process side, an example I'll cite is the awarding of the Information Warfare Research Project, Other Transaction Authority, or IWRP OTA, out of NIWC-LANT earlier this year. And that will allow the consortium to move at speed when we have questions where we think industry can provide something fast. We now have the vehicle with which to pursue that.
You mentioned people also, and your people challenge, I imagine, is in all of the areas that we've discussed, making sure you have qualified acquisition people, making sure you have qualified technology people. You have a ton of all those people, but I imagine it's never enough.
It's always a struggle to compete in the same space where great technology companies are competing across the country, but we compete pretty well in that space. And you got to ask, why is that? Well, it's the mission. SPAWAR warriors are committed to the mission, and I see that every day. And I think that commitment and that understanding of the relevance of their work and the work we're doing to try to remove obstacles, well, we can see that reflected in data. A recent federal survey pointed out that among the Navy organizations surveyed, SPAWAR had moved to number 2. Of course, I want to be number 1, but that's progress, and that's the progress of our people.
What are you doing to help keep the people that you have at SPAWAR? Mission is very enticing. It's tremendously compelling. It's not the only factor. What are you able to do, and what would you like to be able to do to keep the great people that you have?
Well, first and foremost is maintaining that connection to the mission. We're looking at ways to do that, both with connecting to the fleet and the fleet concentration areas, but also opportunities to go to sea and to see our capabilities in play, real time, and get to talk to the sailors and the Marines that are using those capabilities. More specifically and locally to San Diego, we're working with our other Navy partners to assess how we can deliver the kind of facilities, the kind of 21st century facilities that our 21st century technical workforce needs and frankly deserves in order to meet this critical mission.
Admiral, you spoke at West 2018 and you said there, we've got to go faster to maintain the edge that the United States has on its peer competitors. I don't know if you knew that you were going to be previewing the National Defense Strategy, but that's the essence of the NDS. What have you undertaken at SPAWAR, and what have you seen across the force in that subsequent year that gives you either optimism or pessimism that you're going fast enough or you're not going fast enough?
One area where I think we're making progress is in delivering what I refer to as the information warfare platform. And rather than perhaps go into too much detail about the technical description of that, if you bear with me, I'll try to put it in context. If you have applications that are tightly integrated to your operating system, and I've designed that to be most effective for the application, and in fact I've designed it to the point where it runs on specific hardware, I could probably tune that application to work very, very well, just not with any others. In order to move fast, we've got to move to an architecture where the applications and the services, the operating systems that support them, and the hardware and the networking underneath those are not tightly coupled. In fact, they're loosely aggregated. In fact, they're so interoperable that I can modernize at one level without affecting performance from the others. We're making progress in that regard in delivering the information warfare platform. Now, with our ships at sea, it takes time to proliferate through the fleet as we make physical changes to architectures, but the conceptual employment is a reality. And to that, I'll cite a success we had with something called Compile to Combat in 24 hours. Compile to Combat in 24 hours was an idea that turned into reality, where we were able to create code, create a service, a capability, considered much like a new weapon to integrate on an airplane, except software on a network, a capability of some kind. We were able to design that capability, code it, and send it to the ship with all of the authorities, all of the cybersecurity checks, all of the sort of system engineering and testing checks that we needed to accomplish within 24 hours. And we did it twice on 2 different ships. That's reality. That's not lightning bolts in a PowerPoint chart. That is an organization or organizations coming together with a vision and delivering on that vision. Now we have to make that the standard way we do business. And while we continue to modernize the networks underneath, we can, at speed, modernize our processes so that we can move with that kind of alacrity.
When you talk about modernizing processes, one of the observations I made as we visited SPAWAR this week was the emphasis on modernization, not just for the sake of modernization, everything geared toward mission delivery. That was not unexpected, but what I didn't expect was, for example, we saw the lab on which your team is working in virtual reality and augmented reality. I had a chance to fire a weapon. I didn't do badly, but not enough for you to try to recruit me, at any rate. But it was not just Big Bang. We saw an augmented reality opportunity for technicians to learn how to conduct maintenance on server racks. Walk me through the process of understanding where modernization makes sense at that granular level and where you also need to be thinking about it at a more holistic level.
In the world in which we operate, of information warfare capabilities, modernization is, in essence, our sustainment strategy. Because as we have limited opportunities to physically address changes on ships, by the time we get to the point where we are able to make any of those physical changes, those capabilities are now advanced in some other direction, so that sustainment really turns into modernization on a cycle time. You know, at one point in the 90s, we had strategies where you would replace your personal computer every 3 years. That stretched out over time to 4 or 5 years. We've got to find the sweet spot for how we lay out schedules to modernize different kinds of equipment in an information technology-rich environment. So that's why modernization for us is such a key driver of delivering and sustaining capability. Now, at the same time, we have to make sure that our sailors are trained and ready and experienced in operating that equipment and those capabilities. If you ask the average person today in the street how to do something that they haven't really accomplished in the past, whether it's change a tire or tie a bow tie, where's the first place they're going to go?
They're going to go to YouTube.
They're going to go to the internet, YouTube or some other service, and look for someone to show them how to do it. We're going down that path. And we're going down that path with support for services, maintenance services, but also, as you saw with augmented reality and virtual reality, I believe that environment or that capability provides a really rich future for how we can not only update at speed the capabilities and modernize them, but also maintain our sailors' ability to operate, maintain, and sustain that equipment at sea in normal conditions and at sea in challenging conditions, where it'll be most important that they're ready.
As somebody whose first video experience was an Atari 2600, it was pretty impressive to see the environment in which you could look around and experience what was going on, whether it be on the bridge of a ship or the server rack that I could pick up and turn the pieces and so on. How does all of that fit broadly into the 10-year vision that you talked about in the first part of the plan? And yes, you said correctly it's impossible to predict what the future looks like in 2027, but how do you build that strategy with enough off-ramps or potential twists in the road that you can still move forward confidently?
Well, allow me to put that in context. If you think about augmented reality or virtual reality or artificial intelligence or 3D printing, or now we refer to as additive manufacturing, these are all technical, for lack of a better word, things, technical tools with which we can then achieve objectives. And I think that's how we knit them all together into a strategy. For instance, how can I use the capabilities that additive manufacturing provides me to not only deliver items, end items, at places where it would be too difficult to deliver them in nominal ways, but how can I use that capability to come up with designs at speed and iterations at speed that previously I would have to wait, well, much longer than the mission might require in order to spin new designs. I can design at speed, and I can perhaps design things that would not be producible otherwise. Well, that opens up a whole new spectrum of how we should approach capabilities. The same thing goes with AR, VR, cloud technologies. All these technologies are cutting edge, but it's the people who will figure out how to create and innovate and deliver the capability that the warfighter needs. It's people like the folks you met at NIWC Pacific yesterday. It's people like the engineers and physicists and scientists and mathematicians that we've had at places like NIWC PAC and NIWC Land who have been there for 40 years. And it's people like the new professionals that we hire straight out of great universities and colleges in the Southern California region and across the country. People who could choose to go anywhere they want to go because of their skills. And yet, as an example, at NIWC PAC, when we have about 70 slots a year for a new professional program, we receive about 2,500 applications. That's the secret sauce. That's the secret weapon that we have, of those people and what they're going to accomplish with the technology.
Admiral Becker, thanks very much for joining me. I appreciate it.
It's been my pleasure. Thank you so much for having me.
Like a lot of government, the Navy's teaching machines to do human tasks so the humans can do things machines can't. Up next, a preview of the Navy's machine learning future. You're watching Inside SPAWAR on the Government Matters Thought Leadership Network. Welcome back to Inside SPAWAR, presented by Vion and Dell EMC. I'm Francis Rose. Every military branch is studying machine learning as a way to process more data faster. One goal is to free up human brains to analyze information and take action on it instead of having to sort through it all. The organization inside the Navy that's working on machine learning is the Space and Naval Warfare Systems Command. Here's machine learning specialist Katie Rainey on the warfighting problems she's trying to solve.
So I'm interested in being able to recognize objects in different types of imagery. So in particular, satellite imagery and video that might be coming from various different platforms. And we're especially interested in the maritime domain, so being able to detect and recognize ships or other objects. Now, one of the things that I've become interested in trying to solve this problem is, first of all, there's lots of ways that industry is approaching the same type of problem. You know, you can think of lots of applications where you can detect cats or dogs or faces in your photos. And so we're looking at ways that we can use that same technology, but there are a lot of different challenges that come up when you're trying to apply this to, say, ships in the ocean. There is a sparsity of data that you can use to develop these algorithms. Cats just are a little bit different than looking for a particular type of ship that you might see in the ocean, or you might have, gosh, any number of things that can come up. And these happen too in industry, but they end up getting solved in different ways than maybe we can replicate in our case. And so one of the things that I'm interested in doing as a researcher working for the Navy is being able to represent the challenges that are specific to the Navy applications and focusing attention on those.
How much of what you do or what you study is adapting technology that exists, for example, in the private sector, and how much of it is creating something that's appropriate for use in the Navy?
So there's a lot of adapting technology. You know, we read a lot of papers and we go to a lot of academic conferences and try to keep up with what's coming out of the world, of that world. But really, when it comes down to actually building an application, there's a lot of tailoring that can happen. We're not taking stuff off the shelf and just serving it up on our data. There's really a lot of data cleaning that has to happen, tweaking algorithms to make sure that they work, and then really crucially is making sure that they work the way that we expect them to and evaluating them and testing them in the right way.
You have said that there are 3 factors that make machine learning hard for the Navy. I'd like to take you through each one of those. The first one's data, and I imagine part of that at least is just the proliferation of stuff that you have access to now.
Yeah, so we have, you know, piles and piles of data, but sometimes it can be really hard to get at it. There are sort of these data silos. Data exists on different networks and coming from different platforms. And then sometimes it just comes out and it's a total mess. There will be sort of, let's say you're talking about maintenance data coming from some sort of aircraft. And there might be gaps where the mechanic didn't quite fill in what they were supposed to fill in at the time. All sorts of things that are missing. And it takes a lot of manual effort to go and clean those things up. And the tech companies do that. In industry, they put manual effort into doing that. But sometimes the resources just aren't there for us, you know, kind of researchers and data scientists that are trying to work with the data. So that's one of our big challenges.
Before we go back to the other factors, I want to step back for a moment, because when you talk about some of the things that you just talked about there, I think the definition of data is important. What is data to the Navy in 2019? What does that landscape look like? It's not just numbers and statistics and stuff.
Yeah, so data is all sorts of things coming down. So data could be images. It could be all the satellite images that are coming down from the national and the commercial operators. It could be, you know, just the fact that someone repaired an aircraft on this particular day and that they did this sort of thing. It could be the number of MAC addresses that are connecting to a particular network at a particular time of day. All different manner of things, and they all have different forms and have to be stored in different ways and have different utilities and have to go into algorithms in different ways. So there really just is tons and tons of challenges with that.
And yet the maintenance information and back office stuff and all of those kinds of things are just as important to trying to deliver mission. All those things are equally valuable.
In some cases even more valuable, because if you don't have those sort of everyday things working, then you're not going to have the big ticket items working when you need them to.
The second item that you talk about making machine learning hard for the Navy is the computing environment. Is that just an environment in the tip of the spear? It's difficult to compute on a ship or in the air, or is there more to it than that?
So that's one of the big areas. So if you're talking about putting an algorithm that's going to, recognize ships in satellite imagery, if you're trying to put that actually on a sensor, well, then you not only have to compete for sort of the space on that sensor, but you have to go through all the accreditation processes to make sure that those things are going to work. Also, if you're putting stuff out on the ship, you have to deal with network delays. You're not going to be connected all the time. You're not going to be operating in an environment that, say, you operate in when you have an app on your smartphone. And so there's lots of different considerations with respect to that sort of thing.
The third item you talk about is trust, and I wonder what the definition is of the kind of trust that you're referring to there.
So I'm referring to sort of understanding how well the algorithms work and how they interact with the humans that are operating with them. So again, to go back to the smartphone comparison, let's say you're looking at your phone and the labeled one of your pictures of your cat as a dog instead, and you sort of chuckle about it and you move on. But if you are on a ship and you're in a information center and you're getting data coming in and you're on the 12th hour of your shift and you see something got labeled wrong, you're just like, I don't know what this is. I don't trust this, and maybe you're just going to turn it off. So we need to be very aware of how the algorithms that we're developing are going to interact with the warfighter, and making sure that we're not making their job harder, and that we're actually developing things that are going to be useful to them in a way that they understand how it's making decisions and why.
What are the components or steps in doing that? Because that's not just a challenge in the discussions that I've had for people in the military or even people in the public sector. This is a private sector, NGO, everybody trying to deal with the same challenge.
So I think communication is number one. One of the things that we try to do here is to get more communication between the scientists and the engineers and the actual warfighters, so that us researchers can understand the warfighter needs better, but also so that the warfighters can understand what's coming down the pipe with respect to AI. They're hearing a lot of things about how we're going to take jobs and all that sort of thing. But we need some good communication between. We need for them to understand how these things can help them, so that they can give us good feedback about what we can be developing for them in the future. And then there's also sort of making sure that we're deploying them, or we're getting them on the ship in the right way, and that we're testing them in the right way, being involved in demonstrations and exercises to say, okay, well, we think this is going to work. We've tried it out in the lab. Let's put it out on the ship and see, where's it going wrong, and can we fix those things? And working through that process all along.
What does a successful conversation of the kind you just described sound like? What are the people in the field giving you and your colleagues here, and what are you giving back to them so that you wind up giving them the tools or resources that they need to be able to do their jobs better?
So one example might be if we're developing a ship detector and we're going to find all the things in this large satellite image that might be of interest to the warfighter. And we as developers don't want to throw anything out, because we're very cautious. We know that we don't want to miss anything. And so we say, to the analysts, hey, look what we're giving you, this whole list of little chips, and you're going to get some ships up at the top, and there's going to be lots of clouds and whitecaps and stuff down at the bottom. And we think we're doing exactly what they need. We want them to say, oh no, this is way too much information. We can't handle it. We don't like the way that this is displayed. You got this one wrong. Why did you get this wrong? we need to be understanding the things that are bothering them about our algorithms so that we can go back and improve that and hope that we can fix the things and make that better for them.
Dr. Katie Rainey, thank you very much for joining me. I appreciate it.
Thank you.
Virtual reality is not just for gaming anymore. The Navy's using it now to teach sailors and Marines everything from racking servers to firing big guns. An exclusive look inside SPAWAR's Mixed Reality Lab next. Keep it right here on the Government Matters Thought Leadership Network. Welcome back to Inside SPAWAR, the role of information warfare in maritime superiority, presented by Vion and Dell EMC. I'm Francis Rose with the Government Matters Thought Leadership Network. The Navy is exploring cutting-edge tech to help train sailors and Marines. SPAWAR's Battle Space Exploitation of Mixed Reality Lab is experimenting with virtual and augmented reality to train sailors and Marines at sea without the sea. Here, Beamer Director Heidi Buck details the lab's mission.
So this is the Beamer Lab. It stands for the Battle Space Exploitation of Mixed Reality Lab. So we're the Navy's Mixed Reality Lab, and what we focus on in this lab is applications that support Navy and Marine Corps training, maintenance, prototyping, and operations.
What comprises mixed reality?
A lot. So augmented reality is kind of the new thing that's out there. It's where you would put on a pair of goggles and you'd look at the real world, and you might see a simple overlay on the real world, almost like a heads-up display. Virtual reality is where you put on goggles and you see a completely different world. But now mixed reality is kind of the combination of a lot of different things. So mixed reality would be putting on a pair of goggles, looking at the real world, but now all of a sudden those virtual objects can interact with the real world. You can walk up to them, walk behind them, walk in front of them. They understand the space around you, and they can interact with that space.
What's the technology that has allowed the evolution of the things that you've described? Because I think a lot of people are familiar with the individual pieces that you're talking about, but the kind of the cutting edge that it strikes me that you're on is mixing all of that stuff all together.
Well, and so the cell phone industry has enabled a lot of this. A lot of the optics inside the goggles, a lot of the processors inside the goggles are all enabled by the cell phone industry. And in fact, we use cell phones quite a bit in this lab because we do a lot of work with tablets and cell phones, using them for augmented reality as well. And so, the point of this lab is to get all of the commercial, consumer grade, industrial grade hardware, VR, AR, mixed reality hardware that's out there, and figure out how the Navy's going to use it, again, to support that training, maintenance, prototyping, and operations.
What's the implication for the evolution of consumer-grade technology on the work that you're doing, and how do you figure out the strategy that's a year or 2 years or 5 years ahead of you based on the stuff that may be available that isn't today?
That is a hard question.
Yeah.
So we spend a lot of time going to conferences. We spend a lot of time interacting with industry. We have a lot of cooperative research agreements with industry. And so a lot of what we have to do is be talking to industry quite a bit to figure out where they're going to go in the next 1 year to 5 years, 10 years, and then figure out where the Navy needs to go with that. Oftentimes, what industry is developing for AR or VR is great for the consumer product, for inside your house or walking down the street. But oftentimes our use cases are a lot different. So sometimes we have to work with industry to make them tweak it a little bit differently so that we can use it for our use cases.
You kind of anticipated where I wanted to go next, which is what's that dialogue like most of the time? Is it, we would love to have this capability, and they respond by saying, yes, we can develop it? Or is it more one way where they're developing technology based on their consumer base and then the potential for sales, and you're deciding how to adapt it for your use?
Both, because we work with a lot of really small companies that maybe can't respond in the direction that we want to go and are only going to respond in the consumer direction. And then we work with a lot of big companies who maybe do want to work with the government and will respond to some of our needs. So it just depends on who we're working with.
What are some specific applications that you're working on today? And tell me about the evolution of applications that you were doing a couple of years ago and how they've progressed over the years.
So right now we do a lot of maintenance applications. So we'll build either trainers, whether they're VR trainers, 3D trainers, 2D trainers, AR trainers, for maintenance applications. And you know, besides the training for maintenance, there's also the live in the field assist for maintaining objects. So oftentimes that's AR. So we do a lot of maintenance work in here, but we're also building networked trainers to support different Navy groups. So, you know, they need to train on a certain scenario, clearing a building, shoot, no shoot scenarios. So we'll build those types of trainers. And so, you know, I think in the beginning of the lab, we're about 4 years old now. In the beginning of the lab, we spent a lot of time looking at the hardware and looking at the software and kind of figuring out our mission and seeing what directions we might want to go. And now we have so many people interested in working with us that we're going in very specific directions now.
What was that weaning down process like? I imagine that was as difficult as mastering the technology, was deciding here are applications where people may want us to go, which is probably not the most practical for us to explore right now.
And in the beginning, we did write a big document of naval applications for AR and VR, and it was full. It was just full of every idea that we had, and it went in a lot of different crazy directions. But now we're pretty focused on, again, training, maintenance, prototyping, and operations, and so we kind of have a clear path forward, and the people that we work with have very specific needs. So now we're able to whittle it down a bit.
How'd you decide what was what?
It's the demand signal of our Navy customers and Marine Corps customers.
Who are maybe your most active customers? Who are the people that you interact with the most within the Navy and Marine Corps that are helping to determine that trajectory of where you go next and what your priorities are today?
Well, there's a couple of different collaborative groups we're interacting with. There's the Navy's AR Consortium, and so that's a group of all of the different Navy R&D labs coming together and just talking about a variety of things that they're working on. And there's another group that's focused on maintenance as well. So within the Navy, there's collaborative groups, but then obviously, of course, we're talking to a variety of different end users who might be coastal riverine groups or SEAL teams or just really anybody. We get a lot of visitors to this lab. And so it seems like anytime we get a visitor to this lab, they end up wanting to work with us in some way, shape, or form. So we've got a lot of different customers.
You've used the term maintenance a couple of times in our conversation already. And when I think of maintenance in the Navy, I think of really basic things like scraping stuff off the hulls of ships and so on. Am I oversimplifying it, or am I on the right track? What's maintenance in the reference that you've used so far?
It could be as simple as that. It could be repairing, maintaining, turning on or off a really simple part that only has a few pieces, but you're required to know how to take those few pieces apart. Or it could be a giant server rack or multiple server racks that you have to learn how to turn on and off and run and maintain and fix. And so it could be anything. So it could be quite difficult to quite easy.
So that strikes me as fascinating, because the Navy's using the very most cutting edge technology that it has to help its sailors and Marines understand how to do maybe some of the most simple, mundane tasks that the Navy has to do. Am I reading that right?
Well, and you know, we always talk about how our sailors, when they receive this training, it's often PowerPoint training or a big stack of PDF manual, line drawings, a lot of words and text that maybe doesn't resonate with them. So they could read this information and maybe not know what to do with it, or they could visualize it and see it in front of them step by step.
We've talked about the technology that's involved here. The other element of this that sounds to me like is very important is the way that the information is presented, the learning techniques that are used to present the information to the sailors and Marines. Who are your partners in helping to do that?
We've worked with a number of medical groups, Navy medical groups, and a number of Navy training groups. And so, you know, a lot of it involves human testing, human factors, user-centered design, and things like that. And then a lot of it is just feedback from the end user. We'll develop something for them, and we do rapid prototyping in this lab, so very quickly we'll get it to them and we'll get feedback that this was too hard to use or they don't like this, and we'll just go in and change it.
What does the future of the work that you're doing look like? I know you can't predict the future, but what's the evolution look like if we were to have this conversation again in 2 years or 5 years? What do you think you'll be able to do then that you can't do now but you can see on the horizon?
So I think it's going to be mixed reality. So there's just a few headsets out now that are doing true mixed reality, and it's still pretty basic. So I think in the near future we'll be able to have these headsets that really can interact with and understand the real world. You know, another problem that we have is the shipboard environment is way different than your household environment. And so to be able to use these headsets successfully on board ship is a really hard problem. And so I hope that in the next few years that gets solved as well. So now we'll be able to use these really high-tech headsets in the shipboard environment.
I want to go back to something to finish with that we talked about at the very beginning. How much of the success that you have in the future will be dependent on the ability of the consumer market to produce things that work for you, or how much will you be able to separate from that interaction, from that symbiosis in the future, do you think?
Well, from my lab, I think it depends a lot on the success of the consumer market, because my lab buys consumer hardware. There's the possibility to go the route of in-house developed hardware, but that's just not the direction my lab is going, because we're trying to keep it cheap, affordable, reusable for our end customers. So I think a lot depends on where the consumer market's going to go.
And it strikes me that when you consider, I don't know about budget specifics here, but broadly across the military, the cheaper you can keep the technology that you're using and the more familiar that technology is to the end user, better off you and your team will be in developing technology for those platforms. Is that fair?
And the more reusable the technology is, or disposable, or easy to swap out, the better, yeah.
Heidi Buck, thank you very much for joining me.
Thank you.
Up next, more cutting-edge capabilities designed to help DoD maintain a technological edge. And some of them are smaller than a bread box. The nano satellites Naval Information Warfare Center Pacific is building and testing. You're watching Inside SPAWAR on the Government Matters Thought Leadership Network. Welcome back to Inside SPAWAR, presented by Vion and Dell EMC. I'm Francis Rose. The Navy and the entire Defense Department want new technologies to restore the edge they've enjoyed over peer and near-peer competitors. Satellite technology is not new, but the size and scale of the satellites the Navy's developing at SPAWAR are both new. Austin Rosick is their Assistant Program Executive Officer for Space Science and Technology. I asked him what the current state of the art is in small satellite technology.
Well, right now we're working on small satellites to do a number of missions for the Navy and the Department of Defense. We just launched a handful of them. One is called ICECAP, or Integrated Communications Extension Capability, and it's going to fly over the North Pole and try to relay communications from there to here in San Diego to demonstrate that we can talk in real time from the North Pole. Other ones are working on optical communications. Our system called HaloNet will work like a retroreflector. A retroreflector is it's like a reflector on your bicycle, and when light hits it, it goes back to where it came from. So on your bicycle, that's so a car can see you. But with this, we're shining a laser on it from the ground, and that laser bounces off the satellite and goes back to the ground station. And then the satellite itself adds some information to that signal as it goes back to the ground. So we can transmit a lot of information from the satellite to the ground for very low power.
What's the evolution in capabilities look like? What can you do today that you couldn't maybe in the recent past? And what do you see on the horizon that you'll be able to do soon with small satellites that maybe you're not able to do today yet?
There's a lot of things we can do. One of the best things, we can innovate very quickly. They're very low cost, so we can try new things quickly, and hopefully they work, but if they don't, then it didn't take a lot of time or money to do it. By doing things quickly and for low dollar value, we can use some of the latest and greatest technology, either from cell phone technology or other inventions coming out of Silicon Valley or other places. And so we have very good technology versus traditional satellites, which get designed and built over about 10 years, and they use the technology that was available when they started, not when the satellite was finished. So by doing our design quickly and having it done in about a year, we have very fresh technology, and we can do a lot of things.
You focus mainly on two types, cube satellites and nano satellites. Tell me the difference between the two, not just in the way that they look, but how they function and the kinds of missions they can perform.
Okay. Cube satellite started in academia. It was originally a 10 centimeter cube, so about 4 inches on a side. That grew. We started to see some military utility of CubeSats. What you do, they decided to call that a 1 unit CubeSat. So then you stack them together and you can make different sizes, kind of like you can with computers. You can make different units. We found that the 3 unit size, which is about a foot long, is fairly useful for military. And we're starting to look at 6 unit and 12 unit sizes as well to do different missions. Nanosat is a different word used to describe a satellite of generally about 10 kilograms or about 22 pounds or smaller. So they're kind of interchangeable, but we tend to use the word nanosats.
What's the evolution by which you develop the ability to get these things up there? How do you get them there today, and how has that changed over the years?
Over the years, it started with these universities trying to launch CubeSats, and they managed to convince some large rocket guys to put it on when they had spare room at the bottom of the rocket. So they get a very low cost or sometimes even free launch into space. Over time, it's gotten much more popular. Now we've launched dozens at a time or even hundreds at a time, and there are dedicated deployment mechanisms that attach to the rocket that will spit out many of them, kind of like a Pez dispenser. And going into the future, so far we've always launched off of large rockets, but there are many new companies that are building smaller rockets that could, in theory, put these satellites into their own dedicated orbit, which right now we don't get. It's kind of like hitchhiking. You get kind of close to where you want to be, but it's not a perfect ride.
I want to connect that back to what I asked you about earlier about what the future looks like, because it sounds like the future of this looks like really an exponential proliferation of these kinds of satellites in space.
It is. We can do a lot of things. A lot of missions that we have done in space were limited because we could only have a small number of satellites. But now, where we can have many of them, we can see more things more often. We can communicate to more places more quickly. There are a lot we can do. One example, there's a company in Silicon Valley that is building electro-optical satellites. They take pictures from space. They have about 200 satellites on orbit right now, versus some of the larger satellites where there are only a couple of them. So they have to wait until the satellite comes back around the Earth to take a picture of something, whereas this new company, they're taking a picture all the time.
Is the state of the art that you described earlier trending smaller or trending bigger, or am I maybe thinking about it the wrong way?
It depends on the mission. There are different types of missions where it makes sense to go smaller, and some of them where it makes sense to be big. For communications, if you're in a benign environment, it makes sense to have a very large satellite at geostationary orbit. Geostationary orbit means that it's going around the Earth at approximately the same speed that the Earth rotates, so it always seems to be in the same place in the sky. But if you're in a contested environment, then having one large satellite that stays in the same place all the time may not be a good idea. So that's where having the small satellites that can have many of them at once. So we can afford to lose one or two in case something bad happens to them.
From a capabilities perspective, what are you giving the person at the tip of the spear today that he or she didn't have before you had these capabilities?
So some of what we're trying to do is to provide capability on demand to the warfighter, where traditionally, because there were so few satellites, there was a very regimented process to get access to them. You had to go through various approval chains, and it took a long time sometimes. So now, with these small satellites, we can give access directly to a ship or directly to a ground unit and let them use the satellite for a short period of time while it's overhead of them.
Who are your major collaboration partners, both in the Defense Department, maybe even in the Navy, and outside DoD? Who do you work with on an ongoing basis to advance this technology and share lessons learned?
Well, within the Navy, we work with the Program Executive Office Space Systems. They acquire satellites for the Navy. We work with Office of Naval Research, who funds a lot of research efforts, and try to partner with the Naval Research Lab, who also has the ability to build satellites. Then outside of the Navy, we work with the Air Force Research Lab in New Mexico. We've worked with various NASA research centers, but we've spent a lot of time working with NASA Ames in San Jose.
How do you get feedback from the warfighter to determine whether there's some capability that's appropriate for you to study, that's appropriate for you to research, or maybe isn't a good fit for the way that you're able to deliver a solution?
Well, we try to involve them in the whole process. So at the beginning of the design process, we'll bring them in and work through the CONOPS, or concept of operation. How will the satellite work? What are the steps when you submit a request and then the satellite returns the data? What steps happen in that process? So they can give us feedback then. We try to involve them in modeling and simulation. So once we have an idea of how it should work, then we model how well will it work, or what will the results be. And then once we finally have it built, we'll try to bring them into the lab here, and we can test it while it's in the lab. And then the final step, we get it on orbit, make sure it's working, and then we will do an exercise or demonstration with the fleet unit and show that it does what it's supposed to do.
We just have a minute or so left, and you mentioned something earlier that I want to go back to. You referenced the desirability of a certain type of satellite in a contested environment versus a non-contested environment. How does that capability, or how does that requirement determine the kind of technology that you want to put against the need that the end user determines?
Well, I think it's good to have a mix of capabilities. The small sats are not going to replace every big satellite, but where we can augment them, or we can have a backup capability in case there's a bad day in space and we lose one or two satellites. So having many of them gives us a backup plan, and also lets us do new and interesting things that we couldn't do before.
What are some of the things that you want to do that you're maybe getting close to doing, or that you're not able to do yet, but what would you like to be able to deliver soon or at some point in the future?
Well, we're working on optical communications, both with the HaloNet mission that I talked about earlier, and with another active laser mission where two satellites will try to talk to each other with the lasers in space. And it works well going forward because the radio frequency spectrum is very crowded, and you have to reserve a slot to talk up to space or down from space. But when you use lasers, you don't have to do that. There's no requirement to coordinate that. So it makes talking with your spacecraft a lot easier. It also provides higher data rates, and it's the ability to put your communication exactly where you want it. You're not spreading it over the whole Earth when you talk. Mm-hmm. Other things, there are some weather missions that we're looking at. The Navy has traditionally done a mission called radar altimetry, where you bounce a radar signal off the ocean and measure how high is sea level. Right now, the U.S. doesn't have a satellite doing that, but we have a design to do that with 4 small satellites.
Austin Wojcik, thank you very much for joining me. I appreciate it.
Thank you. You're welcome.
Thank you for watching our webinar, Inside SPAWAR, the role of information warfare in maritime superiority, presented by Vion and Dell EMC. For more on this critically important topic, go to govmatters.tv/SPAWAR. A link to the archive session will be sent to you shortly, and if you're requesting a training certificate, look for an email with download instructions right after the webinar. For the Government Matters Thought Leadership Network, powered by Fed Insider, I'm Francis Rose.